we're going to have a session that is a little bit more fundamental to start off with, just so that everybody gets in the right frame of mind with respect to decision support tools and systems. And so I'm going to start off with a really short primer just to get everybody's thoughts in line. And then Kale Naska is going to give us a description of the high-level description of the forecast coordinated operations decision support system. And then I'm going to follow up that with again, a kind of a scoping on decision support tools and decision support systems, and how those might look, and how they may need to look in a FIRO environment. And so it's actually pretty dangerous to have somebody presenting and moderating in the same session. So I don't know, maybe a lapse of judgment there, but we have a couple extra minutes, so I think it's going to work out okay. So good morning, everybody. I hope you enjoy the time that we have together today and find it interesting. And if you have questions along the way for this session or others, feel free to chime in. We'll be happy to discuss those. That's the whole idea, is to learn from each other. Okay, so the first thing is that, decisions are nothing new. And it's not just reservoir operations, it's all sorts of endeavors and every aspect of the business that we're in. And so if you look at that decision maker in the middle, they're always faced with choices, and those choices have consequences and yield results of some sort, and those results actually loop back and become additional information. And this whole time there's new information flowing into the process, and so it becomes very much a cycle. And that's particularly true in water management, where the environment is constantly changing. And so, we know that we're all accustomed to updates of forecast, updates of observed information and conditions. And so this whole notion of information systems and is very common to us, but for the purposes of the workshop today and for thinking about the preliminary viability assessment and how DSTs and decision support systems are going to support that effort, it's really important to kind of step back and look at these from first principles to make sure that we get it right, rather than just collect all the stuff that we already have and hope that it works. So I think when I tend to look at a problem or a challenge or an environment, I like to think about the key questions, who, what, when, how, and why. So it's a good thing to do that in this context as well. And when we think about decision support, we need to think about, who are the decision makers? So is that in this case, the reservoir operator, or is it, are there other people that are making decisions along the way? I would argue that there's a whole community of people who are making decisions associated with water management, flood management, water supply management, observing systems, research, administration, et cetera, et cetera. So forecasters are making decisions about what to forecast. That affects other things as well. So who are the decision makers? It's important for us to think about that as we review the type and quality and content of the information and provided to the tools that we're going to be looking at later today, as well as on Thursday. So the next is, what decisions need to be made. So it's important to catalog those and identify, what is it that you really need to be deciding. And then when do those decisions have to be made? So do they need to be made, now, or can they be made later, or when in the process is it critical to have those decisions made so that you're not necessarily overcome by events. And then another kind of interesting dimension of our work is, how long does the decision maker have to make a decision? So, many folks in the engineering realm like to have all the information available before they make a decision, and that's just not feasible in a real-time system. You have to make decisions based on partial information, and in many cases, just because you just don't have forever to go ahead and make those decisions and to take action. And then beyond that, we need to look at what information is available. And I guess in this context, we need to be thinking about, is there other information that we need to create to help make decisions more efficient and effective and work better. So, but fundamentally, what information is available to assess. And then, as importantly, we're going to see quite a bit of this later on today, and again on Thursday. Is how should that information be organized and processed? I mean, just having a giant pile of information isn't necessarily helpful in a decision-making process. So it needs to be well organized and presented so that you can make sense of it within a reasonable period of time, and that you see a proper pathway to your decision through that. And then, just because every key question has to have a why, you need to understand why it's important, and that might also lead into prioritization of tasks and decisions associated with decision support, and what you work on first and what gets the most energy in our process. So it's always good to look at the key questions, and I encourage everybody to be doing this, thinking about these questions as we look at the gap analysis, and we look at what we have and what we don't have. So what's special about forecast informed reservoir operations when it comes to decision support? So we're in the process of migrating into an environment where we're thinking about using forecast explicitly in reservoir operations instead of just observation. So traditionally, the reservoir ops relied primarily on observations, and there are lots of decision support tools and models that inform and support that paradigm. But when we introduce forecasts explicitly into the decision logic, then it really changes kind of the dimensionality of the decision support information and tools and systems that our operators and others around them will need to make confident and effective decisions associated with releases and storage and impact, et cetera. And within that, then there becomes a need for really the operator to have knowledge of the forecast properties, skill, reliability, et cetera. So that's a dimension that we haven't had historically, and is different about FIRO and its application in the Yuba-Feather and in other places. So, and in addition to that, and John mentioned this a few moments ago, the research and operations partnership is an additional aspect of FIRO that is embraced by most, and really gives us the foundation for moving FIRO beyond what it can be today. And so this is The notion that the operations inform the research informs operations, and both are working together on development planning and real-time operations. And so that the decision support environment then it necessarily needs to include a research perspective and an operations perspective so that it can work effectively for all of the groups that are moving FIRO ahead, both in implementation and in the future.